Mpho, concept getters. Hello, how are you guys? I hope you are good so far. January is treating you well. If you're gonna watch this video after January, I hope the month that you will be in is treating you well as well. And I hope Algebra is coming all right so far, because hey, I've put out a lot of algebraic videos so far out there, guys. So come on, algebra has to be easy so that we can get to the more serious content, and obviously we need application of algebra before we can even get to those ones. So guys, brace yourselves as we go and dive into the concept of unequal real roots. But I want to answer this question, okay? As you can see on the screen, we have for what values of k will the equation have unequal real roots. The equation that they're talking about is this one here that you see here, which is x squared plus 10x equals to negative k. What I'm going to do is the first step, right? You have to first make sure that your equation is presented in a form of what? In a form of ax squared plus bx plus c equals to 0, which means what you should see on the other side of the equal sign should be 0. So I will first transpose the k to make it positive, and then my x squared will have a coefficient which is basically 1, and my x has a coefficient which is 10, and my k will just be k, right? So let's write it first so that you can see what's going on. So I'll say I will have x squared plus 10x plus k is equal to 0, all right? So you can see that your a is 1. Your b is 10, and my c, which is the constant, will just be k. B is the coefficient of x, which is 10. A is the coefficient of x squared, which is 1 here. So what I'm going to do is I will first highlight what I have when it comes to a, b, c, and just say what? A is equal to 1, right? And say b is equals to positive 10. Remember, we also mind the signs next to the number. And then I will say, and my c is what? Is positive k. It was negative here, but when it went to the side of the equal sign, it became positive. Okay. Then now that I have, oh, it doesn't look like a k. Let me make it look like a better k here. So my c is k. So the reason why we need a, b, and c is because when it comes to nature of roots, right? When we're looking at unequal real roots, that's where now you have to ask yourself, where do I apply nature of roots when it comes to delta and discriminant, which is that thing that you get under the root sign of the general quadratic formula. I spoke about it when I was proving the general quadratic formula on the other video, right? So when you have the general quadratic formula, remember you have something like this. You have x is equals to minus b plus or minus the square root of b squared minus 4ac. You remember it all over 2a. Now, guys, I want us to focus on only this part. So I'm going to say my delta. Delta is a discriminant, okay? Delta is always equal to what? B squared minus 4ac. This part is always gotten under the root sign of the general quadratic formula. Now, I will substitute my b, my c, and my a on b, a, c here on the discriminant. Then I'll say delta is equal to what? My b is 10, so I'll say 10 squared minus 4. My a is 1, and my c is k. Remember, there we are looking for value of k at the top there. So how do I solve for k here when there's a delta on this side? You can't solve for it. Now, there's a part on the question that speaks more volume than just substituting the discriminant, which is this part here. They're talking about unequal real roots. What are they saying? Okay, don't worry, guys. Don't worry. I got you, right? When it comes to nature of roots, you have to first understand how many equations are there for different types of roots, and then which one we will use for this specific question. So I'm going to go in here so that we can broaden the concept, and we go like whoop, and I'll say nature of roots. Let me introduce the concept of nature of roots, and so that you understand what it means and what it is and how do you identify it and all that. Okay, so on this one, I'll say we have different different values of discriminants or equations of discriminants for roots, right? The first one, you can just say when your delta. We call this delta, right? This can be called a delta, or you can call it a you can call it a delta, or you can call it a what? Discriminant. Okay, so I'll just say delta is equal to what? Delta, is less than 0, or it can just be greater or equal to 0. Or it can just be only greater than 0 or exactly equal to 0. Sometimes delta can be equal to a perfect square, and other times it may not be a perfect square. A perfect square is a number. When you find its square root, you'll find a whole number as an answer, or a positive integer. Makes sense? That's a perfect square. So now, what about these delta equals to ntontoni? What do they tell us? Every time when delta is less than 0, you know that you have what we call non-real roots, right? And then when it's greater and equal to 0, meaning when it is exactly 0 or it's positive, then we have real roots, right? But then if it is only greater than 0, but it's not equal to 0, just only positive, but never 0, then it means you have what? Unequal real roots. I will explain, don't worry. But then if it is exactly equals to 0, it is not greater than 0, nor less than 0, but exactly equal to 0, then we have equal real roots. Right? And now when it comes to when delta is a perfect square or not a perfect square, we're talking about rational real roots, right? So when it is a perfect square, just know that your roots will be rational. So it's going to be rational real roots. But then when delta is not a perfect square, it means you have what? Irrational real roots. So now I want to explain what this delta is on an equation, right? Let me give you an example, okay? Remember, we said delta is exactly what? It's exactly b squared minus 4ac on any quadratic equation. Given, let's say for an example, you have 2x squared plus 3x plus 1 equals to 0. Roots are what? Are solutions. What are solutions, guys? Solutions are what? X values. After solving for x, the values of x are what we call roots. These are the same things. So when you solve for x, remember sometimes they will say factorize, and you're going to say 2x and 1 and 1 and plus, and you're going to say x equals to negative 1 over 2 or x equals to negative 1, right? This negative 1 over 2 and this negative 1 are roots of this equation. Roots are just values of x when you solve for x, when the other side of the equal sign is just 0. Roots is just a fancy way of saying x values when you solve for x. Do that make sense? So a discriminant tells us the type of the x values we're going to get when you solve for x, if we can just interpret the delta. Meaning on this example that I just gave you here, when you have 2x squared plus 3x plus 1 equals to 0, I can check my delta and say my delta is b squared minus 4ac, which is basically what? 3 squared minus 4 into 2 into 1. Remember, my b is this one, 3, my a is 2, and my c is 1. So b, a, c, right? And I'll say 3 squared is what, guys? Is 9 minus 4 times 2 is what, guys? 4 times 2 is 8, and 8 times 1 is still 8. So I will have 8. And then 9 minus 8 is what? Is 1. So you can see my delta is exactly 1. 1 is basically greater than 0. It means my delta is greater than 0, guys. Do that make sense? And if my delta is greater than 0, it means I expect what? I expect unequal based on this here. I expect unequal real roots. Do that make sense? Because my values of x, if we go back here, my values of x are not equal. We have a minus half and we have a negative 1, which means my roots, my x values are not equal, but they are real. Does it make sense? So delta, basically this just describes the type of solutions you're gonna get when you solve the question. Does it make sense? Again, I can give you another example in this concept, and can just move on the side and say, imagine if we had x squared plus let's say we have what, plus 2x plus 1 equals to 0. Let's start by checking the delta. Delta will be what? B squared minus 4ac. Let's see, which is what? B is 2 squared minus 4 into 1 into 1. What is 2 squared is 4 minus 4, right? Which is basically 0. We know that when our delta is 0, we expect equal real roots, meaning the x values are going to be equal. So let's go back here. Let's see if I factorize. X equals to 0x and 1, 1 plus plus. You see x equals to -1 or x equals to -1. You see my roots are equal because my delta is exactly 0. Does it make sense? So delta tells you the type of x value you're going to get when you solve for x. Clear, right? Now that you understand delta, and again, even when it comes to perfect square, we know that, let's go back to that example I was doing. We found that our delta was exactly 1. Let's go here. Our delta was 1. 1 is a perfect square because the square root of 1 is 1, which means I expect my roots to be rational real roots. According to this, my roots also have to be rational real roots. So when you look at the answers here, this number is a rational number because it's a -1/2, and this one is a -1, which is also a rational number. So my solutions are rational. If my delta was not a perfect square, I would have found my answers having a square root on the solutions, a third, which means we know that the solutions are not rational, they are irrational because our root is not a perfect square. So you can always check every time when you have a general quadratic equation. When you have a quadratic equation, solve for x and see the type of values of x you have, and then find the root on the side and align what the root tells you versus the solutions of x, and see if all these rules about nature of roots really apply to every equation that you found. Okay, but now remember, here I just wanted to introduce these rules and know which one we will apply on this specific question that we got. So let's go back. When you go back here, guys, we can see that the question spoke about unequal real roots. Unequal meaning we need only greater than. Real is greater than 0. So I need my delta to be greater than 0. Do that make sense? Not an equal to, but just greater than 0. And now I already found my delta. My delta is this. So I'll substitute this delta with this part of the value of the delta. Clear? So which means I'll just say 10 squared is what? 100. So I'll say 100 minus 4 times 1 times k is minus 4k, right? Should be greater than 0. And then I'll just solve for k, because remember we are looking for values of k. So I'll say then I'll say I will transpose the 100 to this side of the equal sign so that I can have -4k is greater than -100, right? Remember, we want the value of k, not the value of -4k. So I will have to divide by -4 on both sides. But remember, guys, when it comes to inequalities, whenever you divide an inequality, right, by a negative value, the inequality will change from greater to less or from less to greater. Okay, so even with this one here, I'm going to divide by -4. I will divide by -4, and my answer will be k. It's no longer greater, but it's going to be less than. And a -100 over -4 is going to be positive. 100 over 4 is 25, so it's going to be 25, which means my values of k should be less than 25 for these to work. So we solved for the values of k, guys. This is basically the answer. So if they say for what values of k will the equation have what roots, you have to first understand what roots uses which delta, like which this part. And then you find your delta, you substitute the values of a delta on the equation of the delta that applies for this part, and then you solve for k. And that's how this works for concept, guys. Otherwise, remember to do what they and what they and I'm saying, please, guys, please don't be selfish with the information. Do share. Okay?